In this video, we want to work on problems and ideas of Math League, Algebra part, High School part, grade 87654. We will consider 12 ideas and I will leave 5 homeworks. Last problem of each exam, for example, like this one, I will tell you idea of one number of positive divisors, sum of positive divisors, product of them, rainbow idea, ghost idea, homework one IMO problem, this one AMC problem, this one promise summer camp, like Stanford summer camp for USA, prestigious summer camp. And in next part, we will work on high school part. We will solve this logarithm problem. I will tell you again some ideas here, and you can work on logarithm problem of AMC 2022. Next one is this one, problem 35, last problem of 8th grade. If you want to know, there are around 40-50 important formulas in each topic: combinatorics, algebra, number theory, and geometry. If you want to learn them, as I said, feel free to send message to my WhatsApp number in the description and comments. So for problem 35, I will tell you the algorithm for calculating square root. And we have one problem of AMC can be solved with this. I will search it, and if you want to know that, you can send message to my WhatsApp number. 6th grade, last problem again. The rule in when you want to divide mod 8, we have also for mod 9, mod 11, mod 7, mod 13, and also the general rule for finding them. And there are lots of AMC problems that you can solve with this and other prestigious math exams. Again, if you want to learn them, feel free to send message to my WhatsApp number in the description and comments. The last problem of 5th grade I solved. And also an important idea when you want to find minimum maximum in 4th grade. The problem was so much easy, but the idea is important. We can solve hard problems with this idea. When you want to find minimum maximum, you should consider answer between an interval. You should prove one side with example, one side with proof. Okay, so let's solve the problems. Okay, algebra course 1 contest. Let's try last problem, problem 30. Here we have 1 to 20, let me see, to 22, 23 to 30. Okay. It says if x, y, and z are prime, what is the product of all whole number divisors of the product x, y, z? So the problem is this. If we want to write divisors of x, y, z, because they are primes, we can write the divisors as 1, x, y, z. If you use one of them, they are primes. If you use two of them, x, z, y, z. If we use three of them, x, y, z. And then if you multiply, how many x's are there? 1, 2, 3, 4. X to the 4. Similarly, we can say y to the 4 and z to the 4. As idea 1, let me tell you number of positive divisors. Number of positive divisors of a number is what? Idea 2, sum of positive divisors useful in AMC many math exams. Divisors. Idea 3, product of positive divisors. Here, for example, it was a special case, easy problem, but product of positive divisor in general is what? For number of positive divisors, for example, 24 is what? Is 2 cubed times 3. So if you want to select a divisor, it is 2 to the something, for example, 2 to the 0, or 2 to the 1, or 2 squared, or 2 cubed times 3 cubed, 3 to the 0, or 3 to the 1, because it is 3 to the 1. So you have 4 cases to select 2 to the power of what? Times 2 cases 8. And in general, the formula is this. If n is p1 alpha 1 p2, if prime factorization is like this, pk alpha k. If we consider t as number of positive divisors, you can say alpha 1 plus 1, because power of p1 can be 0, 1, 2, alpha 1. So it is alpha 1 plus 1, alpha 2 plus 1 to alpha k plus. It's sum of number of positive divisors. And if, for example, we don't have positive, so you should multiply it by 2. Why? Because, for example, we know plus minus 1, our divisors are of 24, plus minus 2, and so on. So for each positive divisor, we can consider negative of that. So if we want to find all divisors, we should multiply t by 2. Sum of positive divisors, for example, for 24, let me tell you, it's 2 cubed times 3 to the 1. We can write it as 1 plus 2 plus 2 squared plus 2 cubed times 1 plus 3. Okay. Then all divisors, this one, the power of 2, this multiply, and then uh, between them will be summation. Okay. So this sum of positive divisors. So in general, if n is p1 alpha 1 to pk alpha k, it is 1 plus p1 to p1 alpha 1. For p2 up to for pk1 plus pk to pk alpha k. And for finding this, let me tell you an identity, idea 4, that 1 plus r squared to r to the n equals r to the n plus 1 minus 1 over r minus 1. So here we can say p1 alpha 1 plus 1 minus 1 over p1 minus 1 times to pk alpha k plus 1 minus 1 over pk minus 1. Okay. Now, product of positive divisor for this one, we should use rainbow idea or Gauss idea. Let's see this word. Rainbow idea or Gauss idea. It is also useful in IMO in many Olympiad exams. One problem of IMO can be solved with this. I will tell you it was exactly for which year. Product of positive divisors for 24, for example, suppose product is please 1, 2, 3, 4, 6, 8, 12, 24. If we write it in reverse order, 12, 8, 6, 4, 3, 2, 1, then p squared equals 24. We have 8 divisors, 24 to the 8, so p is 24 to the 4. Okay, or we can call it rainbow idea. It is Gauss idea. If you write in reverse order, why we say rainbow idea? Because it is like rainbow. So in general, it is n to the power of t over 2. Okay, so let me tell you, I am a problem. It is IMO 1994. Okay, one problem related. You have A1, A, for example, something. Then you have an inequality you should prove. That you can solve that problem with Gauss idea. This problem of AMC with sum of divisors. We have lots of other problems. As homework 3, you can solve a promise problem. It is related to product of divisor G of n, A of n. Promise 2022. It is summer camp, prestigious summer camp like SUMAC that is for Stanford. This for Boston University 2022. GNA and sum of divisors, positive product of divisors. We can solve also that problem with these ideas. Okay, so we worked on 5 ideas and 3 homeworks. Let's solve the rest. The next one, high school. Okay, let's try this one. The problems are what? 5, 4, 5, 5, 5, 6. Okay. It is a long problem. The square is this. Which part? Here are the problems. Okay. So we have these problems. Let's solve a logarithm problem, and I tell you important rules because in AMC many exam we have something similar to this. Okay, it says if 2019 factorial is a product of the first 2019 positive integers, for which positive integer k is x equals 2019 factorial, the only value of x that satisfies this. Okay, for logarithm, we have some rules. Let's see how many ideas did we have. I5, I6. Okay, idea number 6 is, for example, when you have log a plus log b with the same basis is equal to log AB. If we have log I7, log A minus log B, it is log A over B. I8, idea 8 is log A, log B to the n of A to the m is m over n log B of A, and idea 9, log B of A times log A of C equals A and A will be cancelled, it's log B of C. Okay, so here it is log 4 of x plus 1 over log 9 of x and by this rule, as a result, we can say log b of a times log a of b equals log b of b, which is 1 by definition of logarithm. So log b of a equals 1 over log a of b. Now we can use it here. 1 over log 4 of x, you can say it is log x of 4 plus log x of 9 plus log x of 16 plus log x of 2019 squared equals k. And then if we've used this part, that we have this, and now here, because we have summation, we use this. So it will be log x 4 times 9 times 16 times 2019 factorial, 20 for 19 squared, which is log x 2 squared times 3 squared times 4 squared times 2019 squared, which is log x of 2019 factorial squared. And x is what? X is 2019 factorial. So log 2019 factorial, 2019 factorial squared. So it is the number that if you raise 2019 factorial to the power of that, it will be 2019 factorial squared, so it will be 2. And then it says, okay, for which positive integer k is this the only value of x that satisfies this? So k should be 2. Okay, we have lots of problems about logarithm in AMC. We can solve them. And how many homework did we have? Homework 3. Homework 4. You can solve AMC problems related to logarithm from AMC 2022. You can start. There are lots of problems related to logarithm. Okay, now let's work on AMC on grade 8. So it will be what? 8th grade 35. Let's solve last problem. It says what is the largest prime factor of the product of all even numbers from 2 through 200. Okay, if you write this product, it is 2 times 4 times 6 to 200. So we can write each of them as 2 times 1, next one 2 times 3. Okay, 2 times 5 up to 2 times 100. So we should find the largest prime from 1 to 100. So 100 is not good, 99 is multiple of 9, 98 multiple of 2, 97, it's a prime number, so the answer is B. Let's solve one problem from 7th grade. What is the sum of the digits of the last 3-digit positive integer whose square is a 6-digit integer? Okay, so we want to find sum of the digits of least 3-digit positive integers. Positive in 3-digit positive integers, so x is at least 100. And it says whose square is a 6-digit integer, so x cubed 6 digits, so it will be at least 5 zeros and at most 5 nines. Okay, 6 nines, sorry. And this one. So we should consider these conditions to reach the best answer. So x cubed is greater than 1000000. And this one is what? This one is 10 to the 6 minus 1. So we know x cubed is less than 10 to the 6, so we can say x. And we should find the minimum number. So from here we conclude that x is less than 10 squared. So x is at most 99. So look, if it is 10 squared, we will reach 10 to the 6. So if it is 99, it will be okay. At most 99, and we want to find the least, the minimum. So x cubed should be at least 10 to the 5, okay? So let's check some numbers. For example, we can use binary search. 550 cubed is what? Is 5 cubed times 10 cubed. It is 125,000. How many digits do we have? 1, 2, 3, 4, 5, 6. Okay, so 50 works. And, oh, sorry. It says who's a square. So we should consider x a square. Sorry. So here, let me erase these things. So x squared is less than 10 to the 6, so we can conclude x is less than 10 cubed. So x is less than or equal 999. Okay, so we should focus on this. It is 3-digit number. So let's consider 500. 500 squared is what? Is 25, 1, 2, 3, 4. We want to use binary search. 1, 2, 3, 4, 5, 6, 6 digits. So the answer at first look, we are working from 100 to 999. We've checked. We know 999 works, 100 doesn't work because 100 squared is 140. 500 squared, we have 4 zeros and 5 squared is 25. So this one works. Now we can check what? We can check 250. 250 squared is what? Like binary search. It's 625. Or we can do also something. We can say, let's calculate square root of this. So we have an algorithm. Let me see. It will be idea 10. Idea 10. Square root of 10 to the 5. 1, 2, 3, 4, 5. You consider this. 3 times 3, 9. 1, 0, 0. You multiply it by 2. The algorithm is this. If you want to learn more or solve more problem with this idea, feel free to send message to my WhatsApp number in the description and comments. So it will be 61. And then 61, it will be 39. Then we have 2 zeros, 31. 2 times 31, 62. Then we have what here? We can write 5, 25. Or we can write also 6. 6 times 6, 36. We have 3, 6 times 2, 12 plus 3, 15. We have 137. Okay, so 316. Okay, so it is 316 point something. Okay, so x is greater than equal 316 point something. So the minimum x that satisfies is 317. Sum of the digits is 7 plus 3, 10 plus 1, 11. So the answer is 11. I told you this one. Also, it was useful in one of the problem of AMC 2020. Homework 3, homework 4, homework 5. You can check my previous video in AMC 2022. For one problem, I used this. I should search exactly it was what problem. If you want to learn more ideas, this problem, want to solve more homeworks, feel free to send message to my WhatsApp number in the description comments. Let's solve from 6th grade. Again, last problem. It says I counted backwards out loud from 2018 by ones. When I said my 50th multiple of 8, how many numbers had I counted? Okay, so let's write 2018. The remainder when divided by 8, you should consider last 3 digits. Okay, so it will be which idea? Let me call it idea 11. Idea 11, last 3 digits for when you want to find mod 8 or remainder when divided by 8. For 4, we have also some rules like this. If you want to learn other ideas, as I said before, feel free to send message to my WhatsApp number in the description comments. So 2018, the remainder is 18 mod 8. 18 mod 8 is 2. So 2018, 2017, 2016. So it is first multiple of 2. Okay, first. Then next multiple of 2 is what? 2018. Next one, 2008. 2000. So it is what? It is an arithmetic progression. It is A1, A2, A3. And we have a formula. AN equals A1 plus N minus 1 times common difference. Common difference here is what? Negative 8, negative 8. So A1 is what? 2016 plus N minus 1 times negative 8. So it will be minus 8 times N minus 1. So 50th multiple, so it will be 2016 minus 8 times 49, okay? So we can write this one as 50 minus 1, so it will be 2016 minus 400 plus 8. So it will be what? 1616 plus 8. So it will be 1624, okay? So now it says how many numbers had I counted? So 2018 up to 1624 minus 1624 plus 1. This 2018 minus 1623. 8 minus 3, 5. 11 minus 2, 9. And here 9 minus 6, 3, and 11, 1 minus 1, 0. Okay, so 395. It is this. Okay. Now let's consider 5th grade. Last problem here is what? Is problem 30. Okay. So let's try problem 30. If my favorite positive number multiplied by itself has the same value as a sum when this favorite number is written 24 times and the numbers are added together, what is half the value of that sum? So let's consider favorite positive number is x multiplied by itself has the same value that you write it 24 times. So it's 24x. What's the half of this value of this sum? So 24x over 212x. Here, because it is positive, we can divide both sides by x. It is not 0, so x is 24. 12x is 12 times 24. And 24 is 12 times 2. 12 is 144. 144 times 2 is 288. Okay, so we've solved this. Okay, let's solve last problem of 4th grade, problem 30. Again, as I said, if you want to solve more problems, if you want to prepare for any math exam, want to learn 40, 50 important ideas in geometry, algebra, number theory, and combinatorics, feel free to send message to my WhatsApp number in the description and comments. Okay, problem 30. It says at most how many 1x3 rectangles that don't overlap can fit in a 5x7 rectangle? Okay, so for these problems, we have one idea. Let me tell you the idea is what I've told you up to 11. Idea 11, idea 12. For problems that you should find minimum or maximum of something, at most or at mean of something, we can consider answer between two values. It is so much important. There are lots of problems that can be solved with these prestigious math exams, summer camps, Stanford, all these things. If you want to solve more problems with this idea, feel free to send message to my WhatsApp number in the description comment. So here, we say answer is at most what? At least one. One part is with example, one part is with proof. So we have 35. If you divide 35 by 3, it will be what? It will be 11 point something. So the answer is at most 11. It is what? By proof. Now I want to find an example. So always work on both sides, because sometimes example helps you to find the answer. Sometimes proof helps you. So let's use an example. For example, here, here, here. Then, for example, you use this one, this one, this one, this one. Then we use this one. Then we use this one, this one, this one. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We found also example with 11. This problem was so much easy. We can solve harder problems with this idea. Okay, so if you want, as I said before, if you want to prepare for this exam or other exams, AMC, BMO, IMO, USAMO, AME, feel free to send, or if you want to learn 40, 50 important formulas and ideas that you should memorize in geometry, algebra, number theory, and combinatorics, feel free to send message to my WhatsApp number in the description comments. Okay, thanks for watching this video. Bye.